background on a lot of like administration, operation, and infrastructure. So currently, I'm a solution engineer in StreamNative. Right. So this is my background: EMC, Pivotal, and VMware. Okay. So agenda for this session. First, we cover. I will talk about nature of Node.js. This will be like a review of what Node.js, what's the difference from other language like Python, Java, right? So this will be shown. This will be the first module. The second module will jump into the Pulsar Node.js clients, right? Talk about all these different function Node.js client provided and what's the property you can set up to connect to Pulsar brokers and start to consume data or produce data. Next module will be microservice. How do you make your Node.js client become a microservice? Use containerize it, so make it run in Kubernetes, right? So there's 3 modules we're going to go through today. So prerequisites, I hope that you have some JavaScript background knowledge, right? So how to write Java scripts, right? How to use Node.js, right? How to run it, debug it, and trace in your JavaScript code. Okay. Another has second one is how to set up Pulsar cluster, how to connect to Pulsar cluster, right? How to check the status of a cluster. Third one is basically Pulsar developer training. You have to go through this training. Okay, adapted review, Node.js best practice, right? So Node.js is very special language. We'll go through it. And second one, develop and run the Pulsar client and containerize the Pulsar clients. Okay, so let's jump into the module 1. Understand the nature of Node.js. Okay, we discuss like, is it single thread or not? What's the event loop? And callbacks, what's promise and async and await. This is critical. And the beautiful thing is the Pulsar Node.js client is already made this very easy for you to write consumer producer. So we will go through this. But back to the foundation, right? You need to understand those concepts, right? It's gonna help you to troubleshoot your Pulsar client. Okay. JavaScript function, right? So everything is callback, right? So when you Google JavaScript, you will see the first thing come up is callback health, right? So how do you mess up? So easy to mess up with the JavaScript. It's callback function. It's easy to write, but easy to get complicated, right? So every function, you write it in sequence like script, right? So it's called JavaScript. So you will expect that you run the script is from line 1, line 2, line 3 to the end, right? But there are many functions like set timeout, set immediate, right? They don't run expected like you expected. We will see some example about it, okay? And also JavaScript, the native JavaScript is from the browser, right? So browser engine embedded JavaScript, right? So browser in the beginning is very CPU limit. So it was designed for single thread, and a lot of the network disk I/O is very slow, and it will block in your browser activity, right? So if you're moving your mouse in a browser, you don't want to see it lagging, right? So it's like your mouse is not moving smoothly. It just jump, right? That means your JavaScript in the backend is not doing its job, right? So the JavaScript using this callback function try to make everything async, right? So it's very important to understand how to write the JavaScript right? So good thing is Pulsar Node.js Client are very safe. They are async in natural, so you really don't need to worry about this, right? Just need to apply a lot of template, then it should work fine, right? So if you need to customize a lot of business logic, right, make every callback simple, right? Try to avoid recursive callback, right? So like in a function, you create another callback function, and you create another callback function, and then you call back the first function. That would be a circle, right? So you never come out. That's not good. Another thing is when you have network I/O, if every function is accessing data like read file, or waiting for network connection, right? Considering create buffer or using batching, right? So good thing is Pulsar Node.js Client also provide those functions. Okay, so this is just a review. So collaborate. This is very simple. I think it's very good example to understand what happened, right? So this is a Node.js code. The basically first set timeout, right? So this first line is about print out log code A at a set timeout 0, right? So it's like in timestamp 0, please print out character A, right? Then you think it's called console.log print out B, right? From this logic, it looks like it will print out A, B, C, D, then E, right? No, it's not, right? So if you check, the answer it print out is B first, right? That's what happened to A. Actually, A been thrown into the callback, right? It's not running in the main thread, right? Second, it print out B because this is the main thread. Then set timeout print out C at 100, so it send it to the queue, another queue. Then console.log D 0, the same as A, it didn't print out, right? So B, then you have your logic here. So you have while loop, go through this time millisecond, right? And you start to do square root about I, right? And go next one, right? As it didn't print out anything. It's just wasting your CPU cycle here. Then you go print out E, right? So logic is a print out B, print out E. Then go to A. It go back to a timeout 0. Then set timeout D, then go back to C, right? So this is the beauty of a JavaScript. You need to understand why here. Okay, so next slide, I talk about this. This is because the reason it print out B, E, A, D, C is because Node.js has event loop, okay? So all the logic here, all the US JavaScript running in Node.js, it goes through those queue. Each box is a queue, priority queue, okay? It goes through a pull, which pull queue, right? Then check queue, close queue, timer queue, then pending queue. So there are many, like also micro task queues, right? So this is a couple like next tick and promise, right? So each queue, if you set timer, set it immediate, any function set by called by set immediate, it will go to this queue, check queue, okay? Then it continue back to poll to run the next statement, right? And if this code triggered by event emitter, something like close, right? And it will go to add the function to this queue, okay? Timer, if you set timer, like we show you in previous slides, right? It will add the function to the queue timers, right? And also pending, if you have some special system event, right, and triggered by operational system, it will add it to pending queue, like reading file system, for example, right? So waiting for network, it will go to here, right? So also there's two special queue called process.nested promise queue, right? Those are special queue, right? It will check first and go to promise, okay? Look like confusing, right? So I'll give you example what happened here. Okay, the same thing, right? So think about it. This is a Node.js code, right? Remember everything from pull queue, right? So when you run the first statement, right, it enter the pull queue, right? And okay, it run, nothing happened. This one is required FS is loading a module, right? So it finish, it go to next statement. Next statement is set immediate. Remember, set immediate is in check queue, right? So when you run this, it go log this function console.log1 didn't print. It go to the check queue, right? Then the next one promise.result.len log2. So this function add to promise queue. Nested, right? This function go to nested queue. Okay. Next one is statement is file fs.readFile. So basically, this is a module to read a file, right? And when you read a file name, it create a callback, right? So in the callback function, you print console log4, set timer, set immediate, then process.nested, right? So remember, those actions all go to different queues. Here, right? Does it run? Does it print? No, right? Then after it scan the this statement, right, and your pull queue continue, print out A, right? So guess what? Which one print out first? This one print out first, right? So the answer is print out A, then nested. Nested is high priority, right? Then promise, right? And then it go to set immediate, check queue, right? Remember this, right? Check, close, timer, pending, right? So this one is A3, 2, 1. So A print out first, 3, 2, 1, right? And it go back to OS, then print out 4 because this one go to the pull queue, right? And set timer. Set timer. So nested is always have a higher priority. So 7 print out first, then go immediate, then go timeout, right? So this is the logic, right? So if you really want to develop a very good Node.js code, you need to remember this event loop, right? It's if you put something back, like in the check queue, and this check queue has calling another callback to check, it will run in the circle here, never come out. Remember everything in check or in nested, right? This is a high priority. Right? If you come into this, never come out, basically your Node.js application is stuck. You never go back to next pull, right? So be careful about this. Okay. Silent. It's okay. So summary. The key point about writing Node.js event loop is very important, right? So don't stop the loop. Okay. Remember the loop here. Don't stop. If you're stuck, your function stuck inside this, never come out, you will have to kill your application, right? Timer should be fine. Timer is lower priority, right? So for pending or close, pending is for system level, right? There's something happened, like you pull a server plug, you lost the power, lost the network, you lost the server, malfunction server, right? You will have something happen here, right? So it will exit, it will kill itself, right? So another thing is you set immediate to batch data, right? So set immediate is like it proof you if you need to send that data out of the server or receive data and waiting for data, right? Using set immediate, right, to send data over. And don't send recursive to nested, right? So if you have recursive callback to nested, it's not gonna come out. Right? So all the callback, it should be async, right? So consider async and await. This is the syntax sugar to wrap up all these different set immediate, nested, all those things. This is very good syntax in Node.js to help you to unblock your event loop. Let's go to the module 2. Okay, so I assume that this is kind of like JavaScript background. In Node.js, is using JavaScript or TypeScript, right? So next module, we talk about the Pulsar Client, right? So Node.js, we provide Node.js Pulsar Client. So first, how do we set up client? The second one is like we about the 3 API, producer, consumer, and reader of the Pulsar, right? So what's the property you need to set up? How do you set create, for example, batching, end-to-end encryption? How do you set it up? So it's pretty easy. Okay, so Pulsar Node.js client limitation. So far, the Node.js client is using C double plus binding. So before you install Node.js client, you need to install Pulsar C double plus client on the server you're gonna run, right? So you will on your laptop you have to install C double plus binding. The R&D team, the community team is working on native API, which kind of like make the C double plus binding disappear, so you can install Node.js client directly, right? But that's still not production ready, right? So, but we are working on it now. The other thing is Node.js is community support. We kind of like maintain it. We kind of maintain it now, but a lot of this is contributed from community, right? So right now it only support client API. There's no admin API, so you cannot create namespace. You cannot retrieve topic status, namespace, tenant namespace, the status, right? So you cannot create namespace. You cannot create tenant. So all you can do is producer, consumer, and reader. Okay, there's no writer. So make it fast. So how do you do Node.js client installation? Right. So first you have to get Node.js and npm ready. So I assume that you know how to set it up in Windows or Linux or Mac, right? So basically, you can in Mac. I use Mac. Mac you can do brew install. It will have npm and Node.js ready, right? And for C double class client library, you can refer to the Pulsar document to understand how to install the C double class client, right? So then you use npm to install Pulsar client, right? So this way it will have Pulsar Node client npm. Then you are ready to write the Node.js. Okay, so in Node.js Pulsar client, there's like many different client language like Python, right? So Java. First, you have to understand how to connect to Pulsar brokers, right? So you need to have initiate a connection to broker, right? So for example, Pulsar with 6650 or 6651, right? once you have the connection, you can initiate a client. Using the client, you can initiate different object, for example, message, producer, consumer, and reader. Okay, we're gonna talk about those one by one. Okay, so first one, client function. What's client, right? So when you create a client, what you can do, right? So you can create producer, right? You can subscribe a topic. Or if you don't want to subscribe a topic, you can use a low-level reader to walk through the topic, right? This means you control your progress on the topic. There's no acknowledge. You read it by message ID or by timestamp, right? There's no acknowledge. You just read it one by one from the topic. Or you can close the client, right? So the main full function like this. Okay, configuration. This basically the property. When you init create a Pulsar client, what you can do, what property you need to provide it. Okay, so basically the property name here and the description here, and that this table show you if it require to specify it here, right? So the only thing you need to specify is service URL, which is your broker or proxy URL, like this one, right? Pulsar protocol, host name and poll, right? Or Pulsar protocol SSL, host name and the poll. Okay, authentication. If you have client authentication embedded, right? So you can use OAuth, you can use TLS, you can use LDAP authentication, right? So you can specify authentication using object property, right? If you have TLS authentication, then or TLS connection, you need to specify this ca.crt, right? Trust search file path, right? So this is a must-have if you have SSL. If you have this SSL connection, you will need this to specify where is the ca.crt, so your client can verify that your broker is signed by this CA. Okay. The other two is about the performance, right? So IOS rate, message listeners rate, right? So if your Node.js client, especially on the consumer side, if, for example, you subscribe two or more topics, right? You will need to increase IOS rate and message listeners rate. It depends on how many topics your consumer want to subscribe to, right? You have to increase it. The default is 1, right? So you assume that you only access one topics. This is an example how to initiate a Pulsar client, right? So constant Pulsar is a variable, right? Require module called Pulsar client, right? And everything is wrapped up as async function. This async callback function, right? In this function, using curly brace to specify your property, right? So you remember, if you have authentication, you use constant, then give it a new Pulsar authentication TLS. I use a TLS authentication as an example, right? In this TLS, you have to specify certificate and private key of your Pulsar role. This is your client search, okay? So it wrap up it belongs to your client, okay? So once you have specified this authentication method, you can insert it into this authentication here, right? Remember, if it's SSL here, you have to specify TLS trust serve file path, right? So specify this CRT here. And also this is required service URL, right? And once you finish the connection, doing your business like consume or produce the data, another await, right? So basically, await will wrap up client.close into timer queue, right? So this way it can be async. You can finish this statement and go to next action in your main pool, the pool queue there. Okay, so once you have the connection, right? So first thing is you want to produce the data, right? So consume the data. We call it message, right? So you need to understand the message data structure, right? So in message in Node.js is an object, right? So you have a property and you have a function, right? So next step we talk about the message function, right? So those are basically the same parameter description and what kind of function this function will return, right? So once you get the message, you can use the getter, right, to get this message coming from this topic. Okay, what's the metadata this message have? What's the data, which is the payload, right? It returns a buffer object in the Node.js. Or you can get a message ID, or you can get a published timestamp, right? Event timestamp, and even can get a redelivery count. Check if the message is being redelivered, how many times been redelivered, right? So you can use this to check. If it's like delivered 3 times and I still cannot process the message payload, then I can send it to that later, right? Or send it back to that later, or discard the message, right? And you can also get partition key from the message. Okay, so this is a message. So what's the property it will be? In the property, especially when you want to create a message, produce a message, right? You can specify what's the payload, right? Using data, what's the payload? What's the partition key if you have partition topics, right? Also metadata of the message. Deliver at, you can specify deliver at or deliver after, right? This is kind of like delay message, right? So I want to send it over, maybe like batch it, right? So you can use these 2 property, or you can create even timestamp, right? So when this message was created from your device, for example, right? So we can use now the function to record the event timestamp, okay? And the other optional property is called replication cluster. So basically, you can embed this as a metadata to tell broker, okay, this message need to replicate to different cluster, right? So if you have a geo replication set up on the broker, this will be picked up and delivered to different cluster. Okay, so let's see what the example looks like. Okay, so this example about when how do you form a message, Pulsar message. It's a very simple example, right? Constant message equal curly bracket, right? And this is the data, this is the payload, right? You can use a buffer, then it will wrap up the string hello Pulsar, right? And you can specify key, partition key, right? So you can specify metadata, right? Event time, right? You can use a date.now to create an event timestamp, right? And replication cluster is, in this example, I'm trying to simulate that, okay, this message from central broker, right? It's gonna replicate to east and west cluster, right? This is a simple example of the message. Okay, so next step is the producer, right? The same logic. Producer has a function, right? So first, send object. So you form the message. In the last slide, you form the message. Then you can feed the message, message into send function, right? So you send a message to a topic. Okay, so actually you can send multiple, right? So if you create 5 messages, right? So you can send message 1, send message 2, send message 3, right? And you can tell it that, okay, after 3 messages, I want to flush it, right? It will flush the message to broker. It will send 5 messages back to the broker. Okay, function close, you close the producer, right? So you can get a producer name, you can get a topic, right? There's a new function called is connected. This is a good function, right? So before you send message, you want to make sure that it's connected, right? Somehow broker may unload it, right? Broker need to be reconnected, right? You can use this before this function before you flush your data, before you send send your object to the broker, right? So I have a high mark here. This is a new feature, right? So this is not in your npm installation, but it will come up soon. Yeah. Also, this is not in our Pulsar document yet. Normally, you put it in the exception handling, right? So if acknowledge is not coming back from broker, right? So after timeout, then you can use this check, right? So you can make this is connected like logic to reconnect or to handle, for example, the broker unloaded, right? So or other couple of situation, then you can use is connect if it's equal to false, right? You can try to re-init the connection or re-init the producer or even like, okay, resend flush the message in the queue, for example, right? So this is for the exception handling. We talk about function, right? So basically, this is basically like object. You have function, you have property, right? So this is a property you can use, right? So, okay, when you create a producer, of course, you need to specify what topic, right? You want to talk to, you want to send to, right? And you can specify producer name, right? And send timeout MS. This is like, if you send a message, right? You can specify, okay, I'm gonna wait for broker to act about the broker. Oh, I received a message. Okay, then if broker didn't respond, right? So then you have to handle it, right? So handle it like, okay, I need to resend, right? If broker is not acknowledged, you either skip or resend the message. Okay, so mass pending message. This is the queue on your Node.js side, producer side, right? So what's the maximum queue before I send auto flush or the message to the broker? Message routing mode, right? So routing logic for the partition topic, right? So I think there's only 2. One is round robin, the other is single topic, right? So this is optional. Yeah, if you have partition topic, Bing would be the best. Compression time, right? So you, in default, producer need to specify if you want to compress the message to save the message size, right? So you can specify that on the producer configuration, what kind of algorithm you use. Right now, we support 4, Z4, ZSTD, or Snappy, right? Also can specify batching enable, right? So default is true. So basically, you don't need to specify it unless you want to disable it. You want to make sure that every message I send out to broker, I need to wait for each message got acknowledged, right? So batch enables basically save you some round trip, right? So if you send 5 message to broker will act 5 message at the same time, save you some round trip. Also, always have properties, metadata of a producer. So this is an example of a producer, right? So you need a producer, right? Create a producer, right? So and inside this, you should be able to create a producer and then set out a property, right? So this is an example of the same function. You can async, say producer send a message, right? So you can send multiple message. Here, I don't use message, right? I use a single object structure here, right? So data, send timeout. Actually, you can wrap this up like using a message object like we show in the first slide, right? So this is another way to do it. The highlight part, public key, private key, and encryption key. This is end-to-end encryption. So your message is encrypted from producer. Broker will not decrypt your message. Everything treated by broker by like the binary. It doesn't know if it's encrypted or not. So the end-to-end encryption like is end-to-end. Message generated from producer is encrypted by producer. So if you want to do the encryption, you have to specify this. This is used async key. So you have public key, private key, and session key, right? So to generate this. So if you want to use this encryption key, you can use another Node.js library to generate a session key. This will be like random stream here, right? You can use another module to generate the key here, right? So it will use the private key to encrypt this session key, right? And so client can use public key to the producer's public key to validate. Oh, this is from this session key is from the producer, right? So I can trust this session key and use the public key to decrypt it, and use this encryption key, session key to decrypt the message here. Okay, so this is kind of how the end-to-end encryption work. Also, await close, right? So you can see that all the function support await to put your function code to the event loop, right? So this is a producer. Next, consumer, right? So the same logic, function, and property. We'll talk about function first. There are more function coming up, right? So you see that acknowledge cumulative, right? So you can acknowledge like batching acknowledge, right? So this is a new function. So let's go back to the first one. So consumer, you can do receive. Receive is async code, right? So once you have one message, it will keep looping it and you return a promise. Promise is basically like Java future, right? So it's a callback, right? So how you can specify another function is like, hey, if the message come back from receive, how do I handle it, right? The other function is kind of overloaded with the number. So the number is timeout, okay? So this is very good for the IoT case, like Node.js, right? So you don't want to keep a connection, right? So I want to receive for 10 seconds, right? And skip the event loop, then do some other stuff, right? And you can work with using a set interval to do receive, right? So make it safe, right? Don't keep listening to the broker for the message, right? So you can set timeout in milliseconds, right? So okay, and once you receive the message, right, you do some business process, right? Send it to other topic or create another command to do something, right? You after you finish your business logic, you can acknowledge, tell broker that, hey, I already concerned. You can you can clean out the backlog, right? I don't need a message anymore. Acknowledge will accept message body here, right? So it's a receive message. Or you can just acknowledge the message ID, so you don't need to put the whole message body here in the parameter here. Then this is I think two versions before you don't have negative acknowledge, right? But this is a new function. You instead of acknowledge, you can do negative acknowledge, right? Or you can do negative acknowledge ID. When you set this, broker receive a negative acknowledge, then it will redeliver the message to the consumer. Okay. Also, you can unsubscribe the whole topic or subscription, and you can close the consumer. Okay. There's a lot of property here, right? So consumer is more complicated, right? So a consumer can consume one topic or topics, right? So so basically you can subscribe multiple topic, right? This is one way to do it. You list, put it into the object array, right? I want to subscribe topic 1, topic 2, make it array, right? Or you can use topic pattern, which means that regular expression. For example, you want to subscribe all the topic name in the namespace will start with ACM, for example. Then it will grab all the topic and subscribe it, right? And you can set up subscription name, right? And most important, subscription type, right? So you have to specify. I think the default one is a share subscription type, right? So if you have like key share or failover, you can remember to set this up, okay? Else you may find different behavior when you subscribe different topic. Subscription initial position. So basically this is when you submit a subscription, right? So where do you want to start from the topic, right? So it can be earliest, it can be latest. When you set up latest, normally is no message coming out, right? Unless produce send out new message. Or you can set up message ID, right? Or timestamp, right? So I want to, for example, I want to subscribe after some kind of timestamp, right? So you will start to do that. Okay, the same thing as the producer, right? So act timeout MS, right? So the same, when you produce a message to broker, producer will expect that broker will send acknowledge, right? Consumer the same. Consumer can receive a message, you do the process. You can specify act timeout, right? So this is the same thing. Negative act redeliver timeout. So basically this is kind of like delay. So if you send a negative act message, right? And you can specify that, okay, don't send it, redeliver it immediately. Maybe give me like 10 seconds to receive or redeliver, for example. Also, receive queue size. From producer, you have the producer queue size. And from consumer side, you have also have the queue, right? So you can keep putting, broker will send push message, like 1,000 message to consumer at a time, right? It's not gonna continue push it. It will set up to like 1,000 message to consumer, then stop. Once you act, then you will keep pushing. So this is kind of like your buffer from your consumer. This is important. If your consumer has come like CPU or memory limitation, remember set this up. other thing is like consumer name, property, metadata, listener, right? So you can specify listener. So here I don't specify listener. So I use this, right? So to separate the business process, right? So just print out and get the payload and make it two stream, right? So if you have encryption key, if you don't specify encryption key here and your message is encrypted, you will get a random binary string. You're not going to see the content, right? So remember, if you have producer with encryption, like property, you have to add this, right? And you don't need to provide session key because the session key will be embedded into the message metadata, message header. It's the consumer will know how to process it as long as you have those two keys. It will find the session key and decrypt it and use the session key to decrypt the message itself. So yeah, this is basically consumer. One is reader. Reader is low label consumer. Let's put it. Consumer is kind of like wrapper of reader and make it subscription. It uses subscription to manage the cursor location where the topic progress you have consumed, right? But for reader, no, you don't have the concept of subscription, right? So very simple. Do you have next message to process? If you have next message, you read the next one, right? Other thing is you can seek. For example, I want to kind of like rolling back time. They say, hey, I want to look at the message 2 days ago, right? So you can do seek. C types then, right? So seek message ID if you know the ID, right? So you can kind of like moving your cursor backward or forward to skip some data, right? So this is a reader function. Basically, you will use, and you see that the star, right? This is a new function. If you check the Pulsar document, online document, you won't see the function here, but it will soon be out because this was already merged into our source code. It's not ready in NPM module yet. Okay, so property, right? So again, reader is similar to consumer, right? So what's the topic name you want to read? Start from which message ID, right? You see that it's not like give you the earliest or latest, right? But you can still use this Pulsar message ID earliest, latest, or specify the ID itself, right? Yep, you can do negative acknowledge deliver. You can do receive queue size, reader name, and read compacted. Read compacted. This is special. If your topic is key share, right? It's not gonna work on. It's a key it's partition with key, right? So it can be compacted, right? So using recompact, there must be key, okay? Must be partition key. If there's no partition key, there's no way to compare the data, no way to get the latest message, right? Because there's nothing you can compare. The whole compare idea is based on the key, right? So be careful. This only works for partition table with a key share. Okay, this is a reader example, right? So similar, right? So basically the template is pretty much the same, right? So await, right? Every function, async function, you can use await. Then create reader. This is a function called create reader. And specify topic and where do you want to start, right? And then you can use your business logic, right? So you want to read 10 times, you can start go through or using a while loop, right? While loop to do has nest. You can use while the reader has nest, right? You can keep reading it, right? Await reader read nest, and then you do your business, right? Then once you finish this, then you can close the reader. Basically, this is the Node.js client function, right? So we talk about connection, we talk about client, what's the object, what's the function, what's the property you can use, right? And also we mentioned a little bit of security, right? So end-to-end encryption, right? And also the authentication property, right? And what's the CA file path you can specify. This is the summary of module 2. So module 3, okay, so right now you understand how to write Node.js, right? So next step, you want to containerize it, right? So how do I make an image and reuse it, right? So I don't want to like send a device, the code, deploy it. You want to automate the deployment, right? So in StreamNative, if you use Kubernetes as a platform, right? So it's built on the Kubernetes, right? So you will want to have your client, Pulsar client, also running in Kubernetes. So the beauty of the Kubernetes is like, hey, if your Node.js client is slow, then you can scale up, scale out, right? Increase more client to consume the data or produce the data. So it makes your operation efforts kind of smaller, so you can focus on your business, right? So module 3 will talk about how to do this. So the high level process is basically lost, right? So first, in our example, this property is hard-coded, right? So encryption key, public key, rows property, especially like Pulsar connector, right? The POL FQDN host name, service name. You want to reuse it, right? So you don't want to hard-code it, right? So the first step is basically how to make those property configurable, right? So and you can use the configuration to export this in URL using the process.env. So in Node.js, process is a global object. It will read the environment variables, right? So you can use process.env to read the external configuration, okay? Next step is create Docker file. This is a maker, right? So basically you tell Docker how to build an image, right? And what not to build, right? So you may include a lot of Node.js module, right? And you can, if you don't need it, right? So if it's only for developer, it's not on the runtime, you don't need it, then you can put it in Docker ignore file, right? And you build an image, test it, and you send the image to registration, then Kubernetes can read the image and deploy it to the cluster, right? So for first step, right? So this is basically the same code, right? So all you need to do is the hard code part, like path, that you replace it with this variable called process.env, right? So this is your variable here, a certificate path, service URL, right? Or TLS trust certificate file path, right? So it's just easy, just like make it environment, right? So then in your Docker file, use the env to specify the environment, right? Remember, so those environment will be read by Node.js, right? And Node.js will understand, oh, this property should go to process global object.env to look at the property, right? So then the Docker file will, oh, this is the path. It will mount it, right? So same thing on the service URL, right? Pulsar hostname FQDN, right? Then the Docker file will work. Okay, this is an example, right? For this is kind of like a template how to make Node.js Docker image, right? So ignore node modules, debug log, and the Docker file itself, right? So you don't need to build a Docker file, include a Docker file. So the Docker file looks like this. What's the base message? Is node 16, right? So what you define the user the worker directory, right? And you copy the package.json. So, and you run npm install. So npm install will find this package.json, which include Pulsar Client, right? So it will know, and you will understand to install the Pulsar Client, right? Then you copy your source code, right? Those code, right? This is probably like you will name it like index.js or server.js or client.js, right? So you just copy the file to the image, right? And the command is how do you start the server, the client, right? So it's no producer.js. I use the producer.js as an example, right? So it depends on what you copy into your source code, right? So this way you can build it using a Docker build X. This is an extension to do cross-platform, right? So mostly in my example, I run Docker in Mac OS, right? So if I do build, it will build Docker image for Mac, right? So if you want to run it in Kubernetes, then you need to understand that Kubernetes running on Linux, mostly on AMD 64 architecture. So if you want to build Docker image for the Linux, right? So you have to specify platform for AMD 64, right? So this is kind of like template how to build it. Then you test it. You use a Docker run and see if you start to produce the data to your broker or not, right? And next step is that you push it to Docker Hub registration, right? To if your image has been tested, then you push the image to your Pulsar Node client V1, right? Next step, basically you deploy the Pulsar Node to KS. This is an example, right? So this template basically is a Pulsar client deployment template, right? So you specify you will just build it image location, right? And you remember that's the environment, right? So the environment name, remember that you have a service URL, right? So it tells you value from config map, right? So where's the config map here, right? So config map can replace the environment, right? So service URL, this is your location. You can change it when you deploy the config map, right? So this way, your deployment can pick up the broker location here from the environment. So this is basically the template you can use to deploy your Node.js from Docker to the Kubernetes. Okay, so to summarize, so basically this is the process, right? What you need to take care of, process.env. So use the process.env to replace the property that you need to change. For example, service URL, subscription name, topic name, right? So if you want to use different consume or produce different topic, right? So you can put the topic name with the process.env, right? And then you build a Docker file, and you need to understand the Docker build process, right? And then you can do the config map here, right? Specify config map, right? So those image, you don't need to change it, and you don't need to specify hard-coded the service URL, right? So, or the topic name or subscription name, right? It will follow the same pattern to deploy your Node.js to the Kubernetes. I have an example how to build a container step by step. That example is so this is how I build the Python producer. The process is basically the same, right? So this is basically the way to init your Python environment, build a Python environment, right? So install Pulsar Client, Python client, right? And then start to using git init using VS Code to build your producer, right? So basically, this is the command tutorial time abroad to create new folder, right? And start to write test producer.py Python, right? So same thing. After it, right? So you write your Python code. I don't know. The Python code is somehow in my GitHub repo. Also, I will share that with you later. So basically, you can write your Python code here. Then you create topic, right? So this is basically create topic command, right? Oh, this is Python code. For example, this very similar, right? Client, create a client, right? Give it a URL, create producer, give it a topic location and different property here, right? So then define callback, right? This is basically the same thing, right? Oh, when this message is delivered, print out message publish, right? So you see that producer start to send async message, right? And once a message is delivered, callback function, right? So this is a Python way. It's exactly the same logic, right? So but different syntax, right? So then you test it locally, right? You run the Python code. Everything here is hard-coded, right? Like the example I show you in the slide, right? So you test the Python code and you start to see that using the Pulsar admin topic state, you can see that, okay, I have 1,000 message in. This pretty much tests that your Python codes can produce the data, right? So next step, add Docker file. You make the container how to write Docker file, right? So you see that this is a Docker file component. You see same syntax, but from different image from Python, right? You give an environment, right? So you copy requirement. In Python, you use requirement.ts. Then you use pip to install the package, right? But in Node.js, it's a package.json. Then in npm install. The same thing. Worker copy your source code, right? And run command, right? So the same concept, right? The same command, Docker build, and push it to the Docker hub with all the tag, right? Docker push. Once push, you can test it using Kubernetes SQ command, right? So you see that run the image, right? And you start to see, oh, message coming in too. Right, so you have right now we have 2,000 message in the broker. This is a producer, right? So next step, environment, right? So like I say, in the beginning, all the code is hard-coded, right? Pulsar hard-coded, service URL hard-coded. You use the same concept to. This is a module called OS environment, right? Pulsar URL, Pulsar topic, right? So this way you can specify Pulsar URL topic outside of your source code, right? And this is the way to test it. You see that I export the environment here, and when you run the Python test code, you see message increase, right? Which means that the environment works, right? So next step, you map another image, right? Then this is the last slide I show you, right? So you use a config map, right? And you use the deployment with the image and with the config map environment, right? This way, your image no longer has the service URL or the topic hard-coded, right? So you have the flexible to reuse the producer to produce the data to different broker or different topic, right? You see that you run it and it message count 4,000. This means, okay, it containerized works. Okay, so this is the logic. So for Pulsar Client, if you want to do containerize, this is the step for Python. And you can do the same on the Node.js. So this is pretty much conclude the module 3.